it has a minimal environmental impact. We're not using concrete, we're not using steel, we're not even using very large amounts of timber. Buildings are getting more complex, the standards are getting tighter, and so GreenBox, because every single part of it does multiple things at the same time, addresses these sort of incoming standards better than many other floors.
In this episode, learn about a new timber cassette system that provides many performance benefits, is easy to install, is low in embodied carbon, and can be recycled or reused. Join Senior Principal Paul Becker and Vice President Kristina Rogers, both structural engineers based in Portland, Maine, as they talk with Harry Crofton about GreenBox, an innovative mass timber floor system.
Hello, everybody, and welcome to our next episode in our Mass Timber podcast series. I'm Paul Becker, and I'm joined today by my colleague, Kristina Rogers. How's it going, Kristina?
Good. Another exciting day to chat about mass timber.
Every day is a good day to chat about mass timber.
Correct.
Today, we're going to dive into something called GreenBox, which is a prefabricated mass timber system, and it's really reshaping, we think, the ways we think about efficient, scalable, and sustainable design. And to join us in that conversation, we're joined by Harry Crofton. Harry's an associate based in our London office, and he's worked on projects across the UK and the Middle East. And he's been a busy person over the last couple of years. He's been working with our core studio and our R&D group to develop GreenBox. And GreenBox is going to hopefully change the way we think about mass timber and prefabrication. Harry, welcome to the conversation. How are you doing today?
Pretty good. Thanks for having me. Always a pleasure to talk about mass timber with you both.
There you go. Kristina, why don't you head us off?
Okay, Harry. So let's start with the basics. We're using this term GreenBox, which I understand is a cassette system. Can you talk a little bit about what a cassette is and how this idea of GreenBox came about?
Sure. So the idea of a cassette really is that building stuff is hard, especially on site. You've got complicated designs. Drawings might not be immediately to hand. You've got bad weather, awkward angles. Whereas in a factory, you can set everything up on a jig. And that means it's on the floor, a lot easier to access. And that means that you can build things to a much higher quality in much more comfort. And then when you go to site, you can then lift it in place and the whole thing can be built extremely quickly with very tight tolerances, with much less reliance on things like weather. So physically, what is a cassette? It could be literally as simple as a couple of joists and some OSB. So exactly what you'd be seeing on a single family home, just done in a factory rather than in the field. But then you're seeing more and more sort of more complex designs coming through right now. Of which GreenBox is one, which has got more complex behavior. It's got composite behavior and special fillings. And so I guess that leads us nicely into what is GreenBox. So GreenBox is a type of cassette. It's in principle, it's very simple in that it is 2 sheets of plywood and some glulam joists in between the two. And that forms a series of I-beams, and that makes it very strong and stiff. But the really unique thing about it is its filling. That's the thing that we've been working on as part of the research and development. The filling, what it does is that it provides acoustic benefits integral to the floor, which is often a weakness in timber floors. And it also provides things like damping against footfall-based vibration. And so that means that while traditionally timber floors have been great at doing smaller scale buildings, GreenBox is much more aimed at kind of a higher scale. And so we're talking multi-story construction. So as well as patented filling, there's a lot of unique details, and we can talk about them. We've learned a lot of lessons from our mass timber experience here at TT, and we feel that the details that we've developed sort of solve a lot of the issues that people practically have with mass timber construction.
So Harry, can I follow up? It sounds super interesting, and I think we're all looking for ways to improve quality and speed of construction. You mentioned commercial or high-rise type of projects. Can you tell me a little bit about what makes this different from other prefabs in terms of maybe span or load carrying capacity or things like that, vibration performance? What can you fill in here for me?
Sure. So the real thing that makes GreenBox unique is the fact that it's an integrated floor system. So when you're working with other mass timber solutions, like for example CLT, um, CLT is essentially a big block of wood. And so that works very well from a structural point of view. But you do need extra layers on top of in order to be able to work with, for example, the acoustics and the vibration. And when you're going into long span floors, that can be a real issue. People don't like working in office where their screen is shaking around when their neighbor is walking around. And GreenBox, what the filling does is it mitigates that, and so you can have very similar performance to what you'd expect from high-tech forms of construction. But at the same time, you get the benefits of using timber, which is the lightweight, the low carbon, the speed of construction, and the reusability at the end of the life.
So from what I've learned about it in talking to you, some of the spans that you're achieving are quite remarkable. Maybe you could just fill us in on some of those, because I think that's a differentiator from where I sit.
When you're working with a solid block of wood and you go into longer spans, the depth, obviously when the span increases, the depth increases. And so that can result in an awful lot of wood when you're using CLT. Whereas with GreenBox, because it's an I section, it means when you change the depth of the cassette, it doesn't really affect the volume of timber that you're using. So you can get, essentially as long a span as you can fit on the back of a truck. So if you need to do a really big, I was looking at the other day at an atrium infill, so that would be a 9-meter span. And so that sort of thing is just not achievable in a lot of different construction systems. But if you've got the depth, GreenBox can do it.
Okay, so the name GreenBox, where does it come from? I feel like you're kind of alluding to that answer, but let's hear it straight from you.
It's as simple as it sounds, really. It's a box. It's a box with a special filling in it, and it's green because it's really it has a minimal environmental impact compared with just about anything else on the market. We're not using concrete. We're not using steel. We're not even using very large amounts of timber. Even the filling can be largely recycled materials, and so from an environmental perspective, it is as green as they come.
So, Harry, everything tends to be moving towards prefabrication, given a lot of constraints on the industry in terms of labor and so forth. But speak to us a little bit about the special detailing or coordination that might be required, or what is your biggest consideration when you're looking at a project and you're talking about prefabrication with a GreenBox system? What are the things that you're thinking about?
First of all, you always have to think about, with any kind of prefabricated system, the services coordination. At the end of the day, you're going to need to put holes through things. Ideally, you want to do that as early as possible so it can be done in the factory. Now, obviously, that doesn't always happen every single time. So you also need to have the backup plan of what happens if something needs to happen at the last minute. And making sure that you do have a plan B to be able to in the field make changes as needed, because that's not just what's going to happen during the build process, it's also realistically what's going to happen during the lifetime of the building. People want to modify it over the lifetime of the building, and so being able to do that is extremely important. The other thing about prefabricated products in general is making sure that when you're doing something like cast in place concrete, everything poured into place, and worrying about those interfaces is much less of a concern in terms of fire, in terms of acoustics, in terms of even water just getting through the joints. So when you're thinking about prefabrication, you need to think a little bit wider than what you would be doing for something like say pouring in place concrete, just to make sure that all those details are absolutely as good as they can be, so that you're not going to get leakage of air or water or other things.
So when we've been talking about GreenBox, I've often been really impressed with the way you've thought about water mitigation and like where water's likely to get into the system. Joints you brought up, but maybe you can tell us a little bit more about some of the ways you've detailed GreenBox or thought about the typical details to mitigate issues in advance with water.
So I think the thing to remember with water is it's not a case of if your building is going to leak. You can't just hope for the best. Your building will leak at some point during its lifetime. So you need to be prepared for that and design for that. What GreenBox does is it's got effectively two lines of defense. The first line of defense is a conventional taping up all the joints and making sure that water doesn't get in there in the first place. But the second line of defense is a very unique concept to GreenBox, and that's making sure that all the joints are open and breathable at all times. So while the top might be sealed up to prevent water from getting in, the bottom is actually more open and can let water get out. And so the trick there is to make sure that you can have your water and your water vapor escaping from the joint, so that if you do get a leak and the joint does fill up with water, it can evaporate out before you cause damage to your structure. And if you've got a lot of water, then in the words of a colleague, it's literally dripping on the building manager's desk, so the leak can be fixed. But at the same time, making sure that doesn't cause problems with your other non-structural things that you need to think about. For example, fire or acoustics. Open joints are in some cases an invitation for smoke or sound to get through, but GreenBox is detailed to basically have your cake and eat it.
So Harry, it sounds like you've tried to do worst case scenario planning, which is really great. What kind of maybe surprises or pivots did you have to do as you were detailing out this system? What was a surprise to you?
I think for me, it's how truly multidisciplinary it got. I'm a structural engineer. When I started this project, I was thinking of it like a structural engineer. So I was thinking about span to depth ratios. I was thinking about floor weights and how you construct it. But over the years, I've had to talk through so many different problems with so many different disciplines, and that's a real advantage of working at TT, is that you can have all this expertise being brought in. So I've needed to think like an acoustician, like a fire engineer. We needed to talk with insurance companies to see their concerns. And so it's from that perspective, it's been a really learning experience to be able to get a sense of what all these other disciplines are doing and integrate it into this one product.
In my experience working with engineers from our Canadian offices and our offices outside of North America, we in general have like a different approach to the way the code's written and kind of flexibility in what you can do. I think that kind of leads to a discussion a little bit about testing, but you want to kind of walk us through how you've dealt with the code in the UK, but also maybe how testing played into that?
Sure, it's actually quite an interesting comparison. The different sort of legal and regulatory environments between the UK and the US. I've always thought that the US is much more of a pragmatic approach, which works really, really well for 99% of situations where you have a single, easily to apply solution that can be understood by everyone. And I think that really got its place. The UK legislation is kind of the opposite. It's woolly, it's hard to pin down, it's very much performance based, and that can be confusing, but it also gives a little bit more flexibility and expectation that you're going to do something a little bit different. And so from that perspective, it's been quite nice to be able to work with that. But at the end of the day, it does come down to testing, and both sets of legislation and both sets of codes are looking for the same thing, and that is to make sure that you can prove that it's safe. And so whatever route that you get there, it does at the end of the day come down to testing.
So, you have an analytical model, you've got all your calculations, sheets and sheets of them. You design this thing, somebody builds it, you put it out in the field and you test it. How did the testing work out in terms of comparison or parity to the analytical model?
It's a really good question, actually. The thing about models is they are, of course, models, and they are simplifications. And a lot of the time when you're doing something routine, you almost forget about the very large numbers of assumptions that go into these models. And it's only when you're really pushing the boundaries and doing something which is a bit new, then it becomes really clear that like I said, the model is only an approximation of reality. And especially with things like fire tests, fire has a habit of doing exactly what you don't want it to do. So you can run models that says that the fire is going to do something, But at the end of the day, it really wants to get into every nook and cranny that you don't want it to get into, and testing is really the only way to prove that it'll be okay in the end.
So, hey, Harry, on the fire piece, does the GreenBox make use of fire tape or fire caulking, or is it really just that the members are fastened together in a way that prevents fire from penetrating a joint?
Yeah, that's exactly it. They are just fastened together in a way that prevents the fire from getting in the joint. The
Okay.
joints, as I said, are open. There are a series of things that slow down the spread of flame, you could say. So
Yeah.
the joints are blocked by wood, they're blocked by gravel, they're blocked by insulation. So the behavior in the joint is more complex than what you'd expect than just simple charring model that we apply to the rest of the cassette. But again, it comes down to testing how exactly the heat of the fire works its way through that joint is something which is very, very difficult to model on a computer, and it's something you need to prove in practice in a test.
Maybe one last thing to cover on the system, because I've thought this is really interesting. So it's a cassette. There's holes between the joists, right, in this like open space. And you've mentioned things like gravel, insulation, etc. But really, there's an opportunity to fill in those spaces with whatever makes sense for the constraints of the project. Is that like not every GreenBox has gravel in it? Is that correct?
There's some flexibility with the joints. The sort of when you have a joint with all of the bells and whistles, that's your Rolls-Royce type approach. But GreenBox, at the end of the day, it's all about the filling, and so the way that you do your joints, there's a certain amount of flexibility that can be done. So, some buildings, for example, they might want to do it in a simpler way, and that's really up to the engineer to make that design decision.
This is a UK kind of prototype right now, and I know you're looking to make it in the US and distribute it in the US as well. What can you tell us about how that is going, and when can we expect to see our first GreenBox here in the US?
So we've got a team in the US that's been studying the local codes and regulations and the local market. I think GreenBox in the US is going to be a slightly different product to the way that it works in the UK, simply because of the way that things are done is different, and the local problems that you need to solve are a little bit different. The UK is leading the way, I guess. Yeah, we're actually actively going to market right now, and our first project. And I'm hoping that the lessons that we learned from going to market in the UK, we can apply to the US market as well.
That sounds good. I'm hoping that Kristina and I can be maybe the first engineers in the US to be able to spec and prototype it here. Hey Harry, we're gonna wrap up today's conversation, but maybe you could leave us with some thoughts about what excites you most about the future of GreenBox and systems like GreenBox.
The thing that excites me about GreenBox is it's a combination of the high quality of it, and that high quality has a knock-on benefit to other trades. Buildings are getting more complex, the standards are getting tighter, and so GreenBox, because every single part of it does multiple things at the same time, addresses these sort of incoming standards better than many other floors. But also just having the confidence that GreenBox is going to do its job means that you can simplify things around it. So that is something that's exciting for me. The other thing is the sort of circularity and reusability of GreenBox. It's a very easy system to just lift in and lift out of the building, and especially when you do prefabricate the rest of the building and you can turn it into a kit of parts that can be broken down and reused or modified over time. I think that's it's certainly something that's becoming more and more of a thing in London, and I think that's going to be more and more a thing across the world very soon.
So Harry, thank you so much for chatting with us today. It's really been a pleasure learning about this system with you, and most importantly, seeing your passion, right? And really just like challenging what's a better way to do this. Let's throw out the notion of CLT is the only option, which was a great option, but like, how are there other ways to approach it? And I think seeing your creativity and passion towards this has been really inspiring.
Thanks. Great to talk to you both.
Thanks, Harry. And hope everybody joins us for our next episode on our Mass Timber podcast. Have a great day.
Tune in for our next episode, Mass Timber and Wider Sustainability Goals. And like, subscribe, follow, or comment.